Okay, so we've set up our cross multiplication. We put our denominators because they have two terms in parentheses. And now we're just going to solve for x. So we're going to distribute here. On the left-hand side, we get 9x plus 36. Good. What do you get on the right-hand side? 6x minus 30. So now I want to continue on and solve for x. What would I do to solve for x? What's one thing I could do? Because there's lots of things. Someone said you could add 30. So we're going to get our numbers together. We're adding 30 to both sides. So now I have 9x plus 66 equals 6x. Now what would you do if you're solving for x? So we want to get our x terms together. So we'll go ahead and subtract the 9x. And we end up with 66 equals negative 3x. What would I do? What's the last step? Divide by negative 3. So when I divide 66 by negative 3, I get negative 22 is equal to x. Okay, so this is us looking at how we can solve for x using cross multiplication. Okay, if you've already finished your rabbit worksheet, the little white rabbit worksheet, or you're still working on it, this might be how you solved. In the rationals unit, we're going to look at another way that we can do this. There are two ways. Okay, so the other way is by finding a common denominator, or in our notes later, we also call it a least common multiple. Okay, that just means common denominator. So it's like what we did in our last rationals unit. If I'm looking for a common denominator of these two fractions, my least common denominator would be x minus 5 times x plus 4. So the first fraction has to be multiplied by x plus 4 so that it can have a common denominator. And the second fraction has to be multiplied by x minus 5. So now they have a common denominator of x plus 4 times x minus 5. So in this unit, we are solving. We're not adding these together. We're not multiplying or anything like that. Well, we found the common denominator in the last unit when we were adding and subtracting. But we're not doing that this time. We are just finding the value of x. So just like when we had same base rule or the log rule where we had log equals log, we're allowed to cross off this common denominator and we just solve what's left. Okay, so once we get our common denominator, we're allowed to just cross it off. It cancels out and we just solve the top. We solve what's left. So I still have to distribute. Maybe I'll write this step out. So I'm still distributing. But if you stop there and look, what do you notice about, do you notice that they're the same? So I want you to kind of see and make that little connection that these two methods at this step, they look exactly the same. So finding a common denominator is another way. And it's nice because when you find a common denominator, you can have more than one ratio equals another ratio, more than just a fraction equals a fraction. You can do this if there are multiple fractions. Okay? You get that common denominator, and once you have the common denominator, you cross it off, and then you just solve what's left. So here we would get the same thing. Last time we added 30, and we had 9x plus 66 equals 6x. We subtracted the 9x, and we were left with 66 equals negative 3x. We divided by negative 3, and we were left with negative 22 equals x. Okay, so they work the same way. So if you haven't finished the rabbit worksheet and you want to use common denominator, you can, because it's really the same thing and it'll look the same as when you cross multiply. So, what? Well, you can, but the trick with cross multiply is it only works when you have a fraction equal to a fraction. And you don't always have that. Lots of times you'll have 3. So I would choose to use common denominator because it works every single time. Okay? It works every single time. On the little white rabbit worksheet, it was always a fraction equals a fraction. So if you want to, you could cross multiply. But most of the time, like here, when we get to this example, number 3, you have a fraction plus a fraction equals a number. Okay? So we could use common denominator. I could also add these together, put it over 1 and cross multiply, but a common denominator will work every single time. So if you're one of my people that likes to be really, really good at one way to do something, instead of having to decide which way would work in that situation, the common denominator will be a better solution for you. That'll work better. What happens if a denominator equals 0? What if you have something divided by 0? What's your calculator say? Error. It says error, right? It's undefined or no solution. It's another way to say that. Okay, your calculator will tell you error. So it's asking us what values of x in the example that we just did would cause the denominator to equal 0. So one of my denominators was x minus 5, and the other one was x plus 4. So if I had x minus 5, I would set it equal to 0, take your denominator and set it equal to 0, and solve for x. And that tells you that the x value in that fraction cannot be equal to 5. Because if I had a 5 here, 5 minus 5 is 0. And that would give me no solution. Okay, the other one was x plus 4. So x cannot equal 5. So that tells me if I set it equal to 0 and solve for x, that x cannot equal negative 4. So in the denominator of that second fraction, if I had negative 4 plus 4, that would make 0 in the denominator. So you can't have that. So when you work with rationals, you always have to check for those extraneous solutions. We call them excluded values. Excluded values. And sometimes they use this abbreviation, E.V. excluded values. Okay, so you always have to consider what numbers would make the denominator equal to 0 and create no solution. Okay, so to find extraneous solutions, set denominators with variables. You don't have to do the ones that don't have variables. To 0, equal to 0, and solve. That's how you find the excluded values. You set the denominators with the variables equal to 0 and solve. Okay, so if I have a denominator without a variable in it, you don't have to worry about that. Okay, so now we're kind of going to do some examples based on what we just talked about. So I can't cross multiply because I have 3 fractions, so my finding a common denominator will always work. What is the common denominator? m plus 5. This one, I'm going to have to fix because it's just a 1. But I could make a least common multiple or a common denominator of m plus 5. So what I have to do is I have to create that on this last one by multiplying the top and the bottom by m plus 5. Remember doing that in the last unit when we were adding and subtracting fractions? Okay, so I should stop and check for the excluded values. I identified the least common multiple. I'm going to identify the excluded values. So if I have a denominator with a variable, I set it equal to 0. And so some of you might already be able to see, just by looking at it, that m cannot equal negative 5. Because if I add a negative 5 right here, negative 5 plus 5 is 0. So I have one excluded value, it's negative 5. So when I get my answer, I just need to go back and make sure that it's not negative 5. Because if it's negative 5, then it's no solution. So now that I have my common denominator, cancel, cancel, cancel. They all match. So now I'm just going to solve the top. 3 plus 7m plus 2 is equal to 1 times m plus 5 is just m plus 5. So I could combine my like terms on the left. And now I'm just going to solve for m. So once you have the common denominator, you're allowed to just cross it off. Okay, so now we're going to move our m's together. 6m plus 5 equals 5. Subtract 5. 6m equals 0. Divide by 6. And m is equal to 0. Okay, so it's good to see a 0 answer once in a while because it looks kind of weird. But 0 divided by 6 is just 0. Okay, you'll have a question? Okay, so sometimes that happens, and it's funny when you get 0 as an answer, it does look a little bit weird. In my last class, they kind of wanted to check. We checked 1. We checked the first one. So if I took 0 and plugged it back in for m, I'd get 3 over 0 plus 5 plus 7 times 0 plus 2 over 0 plus 5. Is that equal to 1? So we could check it. Here I'd get 3 over 5 plus 7 times 0 is 0. 2 over 5 is equal to 1. So yes, it works. So, and you can plug your answer back in and check it and see if it works. You don't have to. But I just want you to see how 0 works, because sometimes 0 looks kind of funny. You want a number. So it's good to have that example, because sometimes we get 0. M is equal to 0, and our excluded value is negative 5, but that's not what m equaled. So this is a good answer. I always would check and see if this is my excluded value, then I would say it's no solution. But 0 can be an answer. Did you want to go back? Did somebody have a question? Haley, did you have a question? Not yet? Okay.
So say n was negative 5, that is no solution. So it can't equal the unlimited.
Can't equal the excluded value. Because that's excluded. It would make 0 in the denominator, and that would make your calculator tell you error. It's no solution. It's not possible. Okay, so we have another one. Number 4. What do you think the least common multiple or the common denominator would be from our last unit? Take a look at those. 6x. Good. So what do I multiply the first fraction by to make the denominator 6x? 6 let's stop right there, and we need to find our excluded values. So I have an x, and I have 6x, and then I have 6. I don't have to figure out an excluded value for 6. You can't change the denominator of that fraction, negative 1 over 6, because this is a constant. It has no variable. It's always going to be 6. So you don't have to worry about that one. The ones you have to worry about are the x and the 6x. Okay, because I want to know what number can't I have here for x that would create a 0. So one of them is just 0. That x can't be 0. And then the other one, I should always solve them separately, is also 0. So x cannot equal 0 here either. So they're the same. If I had 6 times 0, I would get a 0 in the denominator. If I just had 0 for this x, I would have a 0 in the denominator. So 0 is my excluded value on this one. So let's go through and create that common denominator. Do I need to multiply 5 over 6x by anything? No, because it already has my common denominator. I'll go ahead and distribute that subtraction so I don't forget later. Okay. Now, negative 1 over 6, what do I need to multiply this denominator by? It needs an x. Very good. So now they're all 6x, 6x, 6x. You can cancel, 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 and I just solve the top. I always just distribute the subtraction so that I don't forget to later on. Just like in the last unit. I just go ahead and distribute that negative sign in case what sometimes happens, Alexa, is if I were multiplying by maybe something in parentheses that had a couple of terms, I might forget to distribute it through the parentheses. So I go ahead and just change it. Okay? I think it keeps people from making mistakes. So on the top here, I have 6 times 2x plus 1, so I get 12x plus 6 is equal to, I have my equal sign, and then I have 5, and then plus my negative 1 times x, so minus 1x. Now I just solved that. So I'm going to add x to both sides, and I get 13x plus 6 equals 5. So now I need to get my numbers together. So you could subtract 6. And now I need to solve for x. So what do I do next? Divide by 13. And so this one's a fraction. X is equal to negative 1 over 13. I should always go back and check. Is it an excluded value? Nope. What's your excluded value? 0. Is my answer 0? Nope. So it's good to go. It's a good answer. All right, so let's look at the next one. I've got 7n divided by n plus 3 equals 1 plus 4n minus 9 over n plus 3. What's my least common multiple? n plus 3. If n plus 3 is my only denominator, what's my excluded value? Negative 3. Good, because if I had a negative 3 in the place of n, it would create 0, because negative 3 plus 3 is just 0. And I don't want to have 0. So I have to multiply the 1. I could put it over 1, right? Excuse me, sorry. I have to multiply the 1 by that n minus 3, so it has a common denominator. Okay, so now I have, maybe I'll write this one out. Maybe that'll help some of you see it a little bit more. 7n over n plus 3 is equal to, and then this is my 1 times n plus 3 over, and in the bottom I just have, 1 times n plus 3 and then plus my 4n minus 9 over my n plus 3. So they match. Okay, 1 times n plus 3, they're all the same. So I cancel, 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 because they're all the same. So you get to cross them out. And I just solve what's left on the top. Okay, so I'd probably combine like terms first. So on the right-hand side, that would give me 5n minus 6. And then I'm going to subtract 5n to get my n terms together. That leaves me with 2n equals negative 6. And then divide by the 2. And so n, it says my answer is n equals negative 3. But what's wrong with that? It equals the EV. It's an excluded value that is not allowed to be in my answer. So because it's the EV, this problem is no solution. Okay? Once in a while you'll get a quadratic and you'll have 2 answers, and so you'll still have an answer. But this one, it only had 1 answer and the excluded value was the answer, so it's no solution. Okay, so when I see the subtraction sign, what do I do with it, Alexa? Change it to addition and distribute it, and then you don't have to worry about making a mistake with it as much. Okay, I need to find a least common multiple. What's my common denominator? 2x plus 3 times what? Remember from our last unit? Times x. Very good. Okay, because I can't just, put times 2 and a 3 on there. These are all separate. So I'm going to have to multiply them by each other. So the first fraction, what would you multiply the first fraction by? It needs the x. And then the second fraction has an x. It needs 2x plus 3 on the top and the bottom. And then this one has 2x plus 3. It needs an x. Very good. So now, on the bottom, they all match. X times 2x plus 3, x times 2x plus 3, x times 2x plus 3. Oops, we forgot to find the excluded values. So I'm going to stop there and we'll go back. We had one denominator that was x and one that was 2x plus 3. Okay, so what's my excluded value for x? It's just 0. Cannot equal 0. And then this one is a fraction. So be careful with one like this. It's negative 3 over 2. Okay, so cannot equal negative 3 over 2. So because it was 2x plus 3, when I subtract that 3, I also have to divide by the 2. So it makes a fraction. So now I want to solve for x. So I'm going to go across the top and write what I have left. I have x times 9, so 9x. And so now I'm distributing that negative 4. So negative 8x minus 12. You guys agree? And then equal sign, and then 15 times x, 15x. So that's all I have to solve. I'm going to combine like terms. So 9x minus 8x gives me x minus 12 equals 15x. Then I'm going to subtract the x to get my x terms together. So that leaves me with negative 12 equals 14x. Now what do you do? Well, you want to get the x by itself. So which number do you divide by? The 14. Because I want to get x by itself. And then I just reduce. So negative 6 over 7 is equal to x. Is that an excluded value? Nope. because I had 0 and negative 3 over 2. So negative 6 over 7 is a good answer. You can keep that one. Okay, so that gives you another way to do the white rabbit, or you can cross multiply if you prefer. Just be very careful with cross multiply because sometimes people try to do it when there are 3 fractions. Okay, and you could simplify this one and make it 1 fraction cross multiply, but you're already kind of in the middle of the problem. So maybe I think it's better to just use common denominator, and you won't have to worry about, you know, creating a fraction equals a fraction, and it will always work. It will always work. Okay? So questions over this. I want to make sure you guys feel comfortable with it. It's kind of building on what we did in the last unit, right? Except the fun part is you don't actually have to add or subtract the fractions. You just get to cancel out the denominator, solve the top for x. That's all you have to do. What do you think? Okay? All right. Go for it.